Hi everyone, this video is called More Graphs and Displays of Data. In the video to follow, we're going to do a couple of different kinds of graphs and displays. The first one is going to be called a stem and leaf. The next one will be what's called a dot plot. And then we will also do some qualitative. And these are both quantitative variables, and then we'll do some qualitative variables, and some qualitative variable plots will include pie charts and bar graphs. And then I would also like to, if there's enough time, and I'll decide at the end of this, that there's what's called two variable type of graphs, and one is called a scatter plot and the other one is called a time series. And so there are 6 different graphs we're going to do in this video, and you want to be prepared for all of those. Okay, I'm going to switch the screen and then we'll go from there. So above I have listed the grade data for this class. This contains everybody's grade as of yesterday, which was November the 5th. And so November 5th these were the grades in class, and a couple of you missing homework, which you probably turned in today and aren't recorded. But here's the grades, and what I want to do is organize these into a table so I can get a look at what they look like. And the first one I'm going to do is the stem and leaf. Alright? And the way I make a stem and leaf is I look at my data and I see it goes from 20s, 40s, 50s, 60s, 70s, and 80s. So what I want to do is I want to make a table, and this part of the table are called the stems, and this part are called the leaves. And the leaves are usually the last digit that you see. And the stems then will be all the digits in front. So for instance, I see 2s, 3s, 4s, 5s, 6s, 7s, and 8s. Alright? And what I want to do is record the data. So I start going through the data one at a time. 49, and I put a 9 here. 62, and I put a 2 there. 81, and a 1 there. 84. And now I'm going to continue this until I'm done. So I'm going to pause the video, and you should finish this on your own. Okay, your stem and leaf should look something like mine. And one of the things you want to do is you want the numbers in some sense lined up in rows like this, rows straight up and down. And what it does is if you turn it on the side, you should look at your video sideways. It does give you kind of a histogram picture of what things look like. And so a stem and leaf is a great way to organize data in that sense, because it does such a nice job of organizing the data in a nice way. Now, this is not complete. What I'd like to do is I would like to my leaves here are not in order, they're out of order. So what I have done here is what's called an unordered stem and leaf. So I want you to see how easy it is to order these up and make what's called an ordered stem and leaf. So why don't you try that, and I'm going to do it myself. I'm going to do a little erasing and do it right here, and we're going to see the ordered stem and leaf. Okay, so it took me a minute to do that because I had to erase, but if you just did it again, you should be able to see there's the 22, the 49, 55, 58, 59, 60, 62, 62, 66, 68, 68, 69, 69. So everything's all in order, and this is called an ordered stem and leaf. So now what we're going to do from the stem and leaf is we're going to make what's called a dot plot. And a dot plot is just a way of expressing this data in sort of a histogram type form, but doing it really quickly. So you can watch how I'm going to do this. I'm first going to set up an x-axis with my classes lined out so I can see them. All right, and you'll see it when you come back after you pause. So all I've done is I've made a number line with equally spaced marks that represent essentially what I have here on my stems, or what I might have on a histogram. And so I'm doing my classes from 20, 30, 30, 40. Class width is 10. The boundaries are 20, 30, 40, and 50, so everything's here. Now, what I'm going to do is I could start out with the original data. I'm just going to use the data on my stem and leaves. And what I'm going to do is I'm going to put a mark like a dot. I usually use an X. Either one's fine, but I'm going to put a dot and then stack them up as I go along. And what you'll do is you'll get a picture of the distribution of the grades in class. So 22 is about there. 49's right there. Then we have a 55, a 58, and a 59. Then we have a 60. We have now two 62s, a 66, and then two 68s, two 69s, a 70, two 71s, a 72, and you can finish this on your own. I'm going to pause and finish it, and then you can come back. Now I think I got all the dots, and I probably should have made this bigger so it'd be more clear. Here, let me do that so we can see it. And what you can see then is you can see how the dots are spread out across the screen. Now, if you have a lot more data than just we do in class, then what happens is, and I'll do these in blue so they're different, you might see dots going up in certain spots like this, and you would start to see that maybe the distribution has a center or something like that. Now, the reality is with a dot plot, it's just a way to look at the data. And in my case, what I see if I was doing this class is I see, wow, it looks like I have this kind of group of data right here. That looks like my highest scores in class. And then I have kind of this sort of middle group right there. And then I have this group here. They seem to be separated, although you guys are fairly uniform across here. And then I have these two scores out here like this. So the way I look at that is if people get their homework in, I could really see, in fact, these two high scores probably have A's, but they haven't turned some homework in yet. And these scores here in the middle, B's, could probably move up to here. And I could see probably at least half of this group has the potential to move up to a B, get all your homework in, do better on the next couple of tests. And I could see even this whole group, this part and this part here, moving up into the C range. And these guys have a shot at that, but certainly a D passing is within the realm of possibility. And then whoever grade is down here, that just has to do, they have to turn work in, take tests or whatever. And so what it does is it becomes a way for me to analyze what people are doing. Okay, let's go look at the qualitative graphs. So what I have here is some data, and the first thing I'm going to do is make a bar chart out of it. So take a peek at this data. It shows the monthly salary of, say, principals, a first-year teacher, a 20-year teacher, and an aide in a classroom. All right? And what we want to do is we want to illustrate these on a bar chart. And so to do that on a bar chart, you basically make an axis, a vertical and a horizontal axis. And on the vertical axis, you label it with your categories. So principal, teacher 1, teacher 20, and aide. So we label the characteristics, and then the bar graph would be, in our case, it would represent salary in dollars per month. And so then we might have 2, 4, 6, 8, 10,000. And so we might say salary per month times 1,000, and then label these 2, 4, 6, 8, 10. And then all we do is we make a bar for each one. So the principal makes 10,000 a year. The first year teacher makes 3,000 a year. The 20-year teacher makes 6,000 a year, and the aide makes 2,000 a year. And these would then be bars. Now notice how it's different from a histogram, in that a histogram the bars touch, but in this case in a bar chart they don't. Sometimes this is also given the name of Pareto chart. Alright, so we're going to take the same data, and what we're going to do is we're going to use this data and we're going to make a pie chart. And so both of these things can be done in the same way. Now in a pie chart, what we need to do is we need to convert these data into degrees on a circle. So what I always do is I always start with this radius right here, and I work my way around the circle. So what I have to do is I'm going to add these up. So 10,000 plus 3,000 plus 6,000 plus 2,000 is 21,000. And what I do is I take each one of those, take the 10,000, divide it by 21,000, and to convert it to degrees, I multiply it times 360. So in other words, the fraction gives me the percentage, and to get the degrees, I multiply by 360. So go ahead and do that for each part of the pie chart, and come back and see if you did it right. So I have the calculations at the end all done. The first one for the principal, I show you, and take 10,000 divided by 21,000 times 360, and that's approximately 171 degrees. The teacher 1, it's 3 divided by 21 times 360, and etc. for the others, and I get 51, 103, and 34 degrees. So 171 degrees is almost 180. So this will be the principal category of the pie chart. Teacher 1 is 51 degrees, and so what I do is I look at this as a right angle, and I'm just estimating 45 is half of that, so 51's a little bigger. So here's a teacher 1 salary in this 4-person school. Teacher 2 is 103 degrees. Here's another 90-degree angle, so it's slightly bigger than that. So this is teacher 2, which is about twice as big as teacher 1. And then the aide gets the smallest piece of the pie. And so when you do this, this pie chart shows relative amounts. So does the bar chart. And I'm not looking that you do things exactly. I just want you, if I ask you to tell me the degrees that each piece of pie would be on a test, I want you to know how to figure that out. Okay, let's pause and look at the last two graphs. Actually, I just decided that not doing the last two graphs is a good idea. They're really something that we need to do when we get to chapter 9 and we talk about scatter plots. It doesn't really benefit us to do it right now because we're not going to need them for a while. So we'll come back and do those when we need them. So this video's over. I hope it helps when you do your homework. There are some subtle things that if you ask questions on them based on this video and the reading, then we can talk about it in class. But you are now ready to do all of section 2.2. except for any graphs on scatter plots. Okay, thanks.